In lesson 66, we will look at how we can apply the derivatives of trig in solving questions related to tangents and normals. Number 1, determine the slope of the tangent to f of x equals to cos 3x plus sine x at x equals to pi over 4. We know that slope of tangent or gradient of tangent is related to the first derivative of f of x. Taking the derivative of cos 3x, we have negative 3 sine 3x. Derivative of sine x is positive cos x. Now we can sub in pi over 4. Negative 3 sine 3 pi over 4 plus cosine of pi over 4. The angle 3 pi over 4 is in the second quadrant, so sine of the related angle pi over 4 in the second quadrant is 1 over root 2 positive, or if you prefer, root 2 over 2, plus cosine of pi over 4 is also 1 over root 2. So here we have negative 3 plus 1, so negative 2 over root 2. Or if you rationalize the denominator, you get the 2 cancelled, and the answer is negative root 2. Example 2. Determine the equation of the normal to the curve f of x equals the sine of 2x plus pi at x equals to pi over 2. If we recall the relationship between the normal to the curve versus the tangent to a curve is that the normal is perpendicular to the tangent. So say here's your function f of x. Your tangent would be, let's say at this point, would be here, and the normal would then be perpendicular to the tangent. Okay. So what does that mean here? Well, we can find the slope of tangent by relating the first derivative of this function and evaluate that at x equals to pi over 2. Then we can take the negative reciprocal of that to find the gradient of the normal, and then find a point of tangency or normalcy to find the actual equation of the normal. So let's start. F prime of x. This is cosine 2x plus pi multiplied by the derivative of 2x plus pi. Pi is a constant, so technically that's just 2. At x equals to pi over 2. F prime is 2 cos 2 times pi over 2 is pi plus another pi. That's 2 pi. We know that cosine 2 pi is 1, which means that this is equal to 2. In other words, the gradient of the normal is the reciprocal negative 1 over 2. We also need to know the point of tangency or normalcy in this case. So f of pi over 2 is sine of 2 times pi over 2 is pi plus pi 2 pi, which is 0. Okay, so we will use the slope of negative 1/2 and the point pi over 2 and 0 to find the equation of the normal. I'm going to use 2-point form. If it helps, I'm going to put the equation here. So 2-point form looks like y minus the coordinate y coordinate equals the slope multiplied by x minus the x coordinate. So y minus 0 is y, m is negative 1/2, x minus pi over 2. This turns into slope y-intercept form plus pi over 4. And here is the equation of the normal. Now take a look at example 3 on the next page. Here we have example 3. Determine the acute angle formed between the tangent to the curve of y equals to arctan x at x equals to 2 and the y-axis. Let me try to draw the tangent at x equals to 2. Is that good enough? Should be okay. And we're interested in the angle between this line and the y-axis. So here we go, this angle here. In some ways, we can make use of the rise over run or the rate triangle drawn anywhere using this tangent. So first of all, let's figure out the slope or the gradient of the tangent at x equals to 2. Gradient of y equals to arc tan x at x equals to 2. We need dy by dx. And from your formula booklet, this is 1 plus x squared. Let's evaluate it. At x equals to 2, this is 1 over 1 plus 2 squared, which is 1 over 5. So that means when you draw a rate triangle, the slope, the rise is 1, the run is 5. Of course, this is not drawn to scale. In this case, in order to find theta, we can make use of tangent, because tangent of theta is equal to 1 over 5. In other words, theta would be arctan of 1 over 5, which works out to approximately 0.197 radians, or if you prefer, 11.3 degrees.